we're familiar with exponents and some of the properties, we're going to do the same stuff but with negatives and see how that affects like what type of numbers we're dealing with. So it says, based on the following patterns, determine the values for negative 2 to the negative first, 2 to the negative second, 2 to the negative third, 2 to the negative fourth, and so forth. So look at the pattern that's happening. So we have 2 to the fourth is 16, but 2 to the third is 8, 2 to the second is 4, 2 to the first is 2. What's happening to 16, 8, 4, 2? What are we doing each time? Well, let's go down though. So how do you go from 16 to 8? You're dividing by
4.
Nope.
Wait. 2.
2, right? And then 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 1 is 1. So if we keep the pattern going, what's 2 to the negative first? 1/2. And guess what 2 to the negative second is? 1/4. And what's 2 to the negative third? 1/8. And what's 2 to the negative fourth? 1/16. Okay? So an exponent is there to show you how often you have a 2. But when we have -1, instead of having 2, it's like almost its inverse, right? So it's 1/2. So behind it, I know it's kind of tiny, but this is really just 1 over 2 to the first, right? And this is really just 1 over 2 to the second. And this is just 1 over 2 to the third. And this is just 1 over 2 to the fourth. So notice whatever exponent they have, it's the same exponent. So to the negative first, 2 is to the first, but now it's in the bottom and it's positive. 2 to the negative third, 2 is to the third, but now it's positive and it's in the bottom. So in a nutshell, negative exponent rule number 1 is move your base to the denominator and make the exponent positive. So this is just going to be 1 over a to the n. So move to denominator, make exponent make exponent positive. So when I teach this in my other classes, I always just kind of say, a negative exponent is screaming at you, I'm in the wrong spot. Put me in the right place, okay? And once you put me in the right place, I won't be negative anymore. I'll be happy. I'll be positive, okay? So with all of these, I want you to show your work. We're not just plugging these into our calculator. I want you to show me you know the rule. So on example 1, what is 5 to the negative second? Its first move going to be 1 over what?
1 over 2.
Well, 5 to the second, right? So your base stays the base. It just gets moved to the bottom. And then your exponent stays the exponent, but it just becomes positive, right? And don't we know what 5 squared is? 25. So this is really equivalent to 1/25. And we just did that without a calculator. What about 10 to the negative third? What's the first move we make? It'll be what?
1 over 2 to the second power.
To the third,
Oh.
right? It's okay. You knew it. You knew it. And you had the positive there. And then what is 10 cubed? Well, 10 times 10 is 100 times another 10. It's 1,000, right? So this is 1,000th. This is kind of interesting. What's 8 to the negative first power going to be? What's our first move? 1 over 8, oopsie, I'm like ripping my paper to the first, but that's just 1/8. So it's kind of interesting. Negative exponents are actually kind of another way to write fractions, which you never maybe knew before. All right, so we need to know these rules, because obviously those 3 we could just plug in our calculator and hit math frac and they would tell us. But that wouldn't help us for these when we have variables there, right? So let's just pay attention. So how are we going to write x to the negative 10th? What's our move that we're going to make?
1 over x.
And then he's going to be raised to what power? The 10th. Can we do anything more? No, because we don't know what x is. So that's going to be our answer. Here, notice both x and y are in the parentheses, so the whole thing's raised to -2. So it means the whole thing is going to go to the denominator. So this is 1 over xy to the what power? Second. They should take that, but if not, we can just use our rule that we just learned before. This is the same thing as 1 over x squared, y squared, right? Both of those are equivalent answers. And why the second one might be helpful is if for some reason they finally give you an x, but they don't give you a y, you at least can do the x part, right? Square the x part and get a coefficient. All right, this one, what you want to just pay attention to, it's not the same as the 2, example 2. What's different is on this one we don't have parentheses. So that negative exponent just goes with what base?
Y.
Just the y, right? So what does the x do? He hangs out on top, right? And the y will go to the bottom and become y to the second. So if you don't have a negative exponent, you're where you're supposed to be. So hang out there, right? If you have a negative exponent, be moved to the other spot, and you are now happy that you're in your own spot. Okay? So with that in mind, we're not really deriving exponent rule number 2, but we can make sense of it, all right? Because I'm going to kind of go off to the side and show you what it is. If we had this, we can use our rule from the last section where we can kind of distribute, right? So this is a to the negative n over b to the negative n. But what you want to notice is the negatives mean I'm in the wrong spot. So it means the a needs to go down below, and the b needs to go up above. But guys, that's the same thing as b over a all to the n. Okay? So that's kind of the derivation of it. You don't have to write that down if you don't want to. Just realize that if you have a whole quotient raised to a negative power, you can just flip it, okay? They're just, both parts are in the wrong spot, so just flip them to where they need to go, and they'll be at that positive power, all right? So we're going to do it with, again, numbers that you can technically put in your calculator, but we're going to make sure we know our work so that when we go to the next 2 examples, we can do it with the variables, all right? So notice both 3/4, both 3 and 4 are to a negative exponent, so they're both in the wrong spot. So this will become what? 4/3 to the second. So you just flip where they are. So now the 4 is on top and the 3 is on bottom. And since they're in their own spot, they're happy now. So the exponent becomes positive. But then we know what 4/3 times 4/3 is. Just square the top, square the bottom, right? So what does 4/3 squared become? You got it. And this one, like I said, you can put it in your calculator and it'll give you that answer. All right, over here it's the same thing. We have 1/2 to the negative 3rd power. So they're both in the wrong spot, so we're going to just flip it, and it's going to become 2/1 to the 3rd power. But what is 2/1?
2.
2. So this is just really 2 to the 3rd power, which is what number? 8. Yay. And we did all of that crazy exponents without, so isn't that weird? I know we don't ever I don't know. I was the type of student that I would just do it and mimic and go and not question it. But looking at example 2, guys, another way to write 8, the number 8, another way to write it is 1/2 to the negative 3rd power. Would you ever think it? You know what I mean? Like you could write 8, like if I said, hey, give me another way to write 8, you might write 2 times 4.
All right, 8/1.
8/1, yes, the easy way, right? So there's so many different ways to write these numbers that we didn't even know existed. It's kind of crazy. All right, so we're just going to do the same thing but with variables. So x over y, all of it's to the negative 5th power, so we want to flip-flop it so they're happy. Y is now over x, and it's going to be to the 5th power. And that should be good enough, okay? So we are done. Because we don't know what y or x are. Is that right? Yeah, because they're plural. We don't know what y or x are. That sounds weird. So we can't raise it to the 5th power, so we're just done at that point. Here, again, notice everything in the parentheses is to the negative 4 power. So we're going to flip everything. So this will be b squared over 2a, everything to the 4th. But look what we have here. We have a number that we know if we distribute it, we could do it. So if we wanted to, do we learn that? Sorry. Okay, I'm going to teach you a different rule. So we can, even though we didn't do it on that last worksheet, we can do the distributive property but with quotients as well. So this is the same thing, guys, as what's b squared to the 4th? That's b to the 8th. And then this is 2 to the 4th, a to the 4th, right? We can distribute him to all the same parts. But the reason why I did it here and not over here, and we can write it over here. This is y to the 5th over x to the 5th if we wanted to write it. It just didn't really get us anywhere because we didn't know what y or x was. But here, what can we do? We can actually get a coefficient there, right? So this is equivalent to b to the 8th over, what is 2 to the 4th, 16? A to the 4th. A lot there. All right, if you're okay with that, go ahead and flip it over. This is just showing you kind of how I proved the thing on the other side. If you have a negative exponent, it's just screaming I'm in the wrong spot. So notice here, A has a negative exponent of m, so that means he's in the wrong spot. So where would he go? Bloop, right down to the bottom. And then here, notice B has a negative exponent, so what's it mean? He's in the wrong spot, so where does he go? Up to the top. So in a nutshell, if you have a negative exponent, just wherever you are, you need to be in the opposite location. So if you're up top, go to the bottom. If you're in the bottom, go to the top. All right, so looking at example 1, he's negative, so where does he need to go? To the bottom. Look at him. He's negative, but where does he need to go since he's already in the bottom? To the top. So I don't even want to memorize the rule because there's lots of A's, B's, M's, and N's, right? I just want you guys to pay attention to negative exponents just means I need to go to the opposite floor, right? If I'm on the ground floor and I have a negative exponent, I need to go to the basement. If I'm in the basement and I have a negative exponent, I need to go to the ground floor. Just kind of keep that in mind, all right? So as we go here, this is kind of interesting. -2 is not an exponent, right? He's just a negative number. So he's going to stay where he's going to be. What about x to the third? Does he need to go anywhere? No, he's positive. He's happy, right? So he's going to stay there. Over 8, again, is just 8 to the first, so he's where he needs to be. But what do you notice about y? He's negative. He's not happy, so where does he need to go? Up to the top. After you have kind of everything in the right location, then ask yourself, can you simplify? Yeah. So I don't try to simplify and move at the same time. I do one or the other, okay? So I got everything in the right spot, so I have my positive exponents, but I can simplify the 2 and the 8, correct? So this will just be -x to the third, y to the fifth, all over 4. If you put a 1 there, I won't count off. My math lab might. I don't know if they accept 1 as a coefficient or not. Has anybody tried that yet? So 2 goes into 2 one time, 8 goes into 8 4 times. All right, here. Is that 8 where he wants to be? Yeah? What about the x? No, so that will just become what? 8x squared. And we don't even need to write over 1, right? You don't write over 1 unless you're trying to do math with fractions. All right, let's look at example 4. Is -10 where we want him to be? He is. Just because he's negative doesn't mean he's mad. He doesn't have a negative exponent, right? And that's what gets tricky. That's why I put it there. So he's just a negative number, but his exponent's technically what? A happy positive 1. So he's happy where he is. What about the x? So he's happy. What about the y?
Negative.
He's not happy, so he's going to go to the other floor. What about the z?
Negative.
So he's going to go to the other floor. Do you see that? So they just, I know it's a cheesy analogy, but if you have a negative exponent, you're not happy with where you are. So you need to go to somewhere where you'll become positive. It's kind of stupid, but it works. All right, so starting with this one, there's a couple different ways to do this one, okay? So I'll do the one way, which kind of goes with what we've been doing, right? Just move them to the correct spot of where you want them, right? So is this y to the 8th happy? No, so where does he need to go? The bottom. Is this y to the -3rd happy? No, so where does he need to go? The top. But then notice that they're the same base. They're both y. So technically we can reduce them or simplify them using the rules we just learned in 5.2a. Couple different ways to remember it. The rules in 5.2a said if you have a quotient, you subtract exponents. It'd be negative, so he needs to go to the bottom. Or the way I teach it is, remember, the little guy's always going to knock out at least some of the big guy, right? So that y to the 3rd is going to knock out 3 of the 8 y's on the bottom, but how many are still going to remain on the bottom? 5. So you can either think of this and go right to 1 over y to the 5th, or like Corey said, this was y to the -5th, but he's not happy, so what's he going to become? 1 over y to the 5th. Right? See how you get to the same answer either way? So you can use the subtraction rule, 3 minus 8 is -5, but since it's a negative exponent, I need to go to the bottom. Or just realize these 3 y's will knock out 3 of the y's on the bottom, but he had the most, so they're going to remain there. Or you could have actually used the subtraction rule from the very beginning. -8 minus a -3 is really -8 plus 3 or -5. So you didn't actually have to do any moving on that one if you didn't want to. There's like, what is that, 3 different ways right there we could have done that. Okay, here this is kind of the same idea. You can move them all at the same time, or you can combine them first and then move them all at once. It's totally up to you, okay? So I don't know why, but when I see this, I initially think combine them. Like I want to get them together. So I write this as x to the -13th first. Anybody like me? You see that? You want to get them together? Okay. But is he happy? No. So what does this become? Yes. Or another way we could have done it is just say neither one's happy, so let's just move both of them to the bottom. and then combine them at the end, and what would you have gotten? The same thing. So there's not really like you're used to an order of operations. When it comes to these, there's not really an order of operations. Either combine them first and then get them to the right location, or get them to the right location and combine them. It's totally up to you which one you prefer.